Hey guys, this video notes is the continuations of our unit 5.3, okay? So in 5.3, we are dealing with exponential functions. So this first set of properties, this one says properties of exponential function, which is provided with f of x equals a to the x. A is the base, okay? Where in this particular problem, it wants the base to be greater than 1. So what I'm going to use in this one is, in this example, I would like to use a base value that's bigger than 1, like 5/2. That's a base, okay? It's bigger than 1. So I can use 5/2, or I can even use f of x equals, let's say, 11 to the x power. These are all the bases, okay? So this right here is the base, and that's all the base, and they're both are greater than 1. So based on these properties, which means it's always true, the domain, it's always a set of real numbers, and the range is a set of positive real numbers, okay? And again, the property means this will always be true. For your exponential functions, there will be no x-intercepts at all, and the y-intercept is always 1. You will have a horizontal asymptote as x approaches a negative big number, negative infinity, and the horizontal asymptote is y equals to 0, which is on the x-axis. Okay. For this particular function, it's going to be an increasing function, and it's always 1-to-1. Because it's always 1-to-1, when you are looking for an inverse function, it will also be a 1-to-1 function. This particular graph has 3 points, 0, 1, 1 comma a, and -1, 1 over a. And you will need to know these points. These 3 points are so important, okay? Important. You have to know those points. You don't need to memorize them. Don't memorize points. Just understand that, hey, when I'm asking for 3 points, I'm really asking for this. This particular graph is smooth, continuous with no corners or gap. Okay, so here is a little picture of our exponential function over here. Let's use what we have over here, i.e. f of x equals 11 to the x. Okay, so notice how you have 3 points here. Okay, if I have 11 to the x, the 0, 1 obviously will stay at 0, 1. But when x is 1, okay, it says 1 comma a, and a is your base. So your base should be 1 comma 11. And when x is -1, it should be -1 comma 1 over 11. That's what it means for those 3 points. Okay, you have an HA, a horizontal asymptote, at y equals to 0, and that is always true. In addition, it says, hey, it's an increasing function. Increasing function means as x is increasing to the right, y goes up, which is true. See this right here? As I'm moving my pen to the right, y is increasing, which 3 points right there. Okay, so all of these statements are true. It's smooth, it's continuous, I don't see any corners or gap. So that's what's happening when the base is positive and bigger than 1. Okay. The second set of properties, which are very similar, except that in this particular case, it wants it still positive for the base, but it wants to be less than 1. So what does it mean by less than 1? So an example would be f of x, a base that's less than 1 is 2/5. Okay, that's a base, but because it has to be in a set of parentheses, because I'm raising it the whole thing to power of x, that's a base. I can also have a base of what? 1/7, that works, right? That's positive, and it's going to be bigger than 1. So any one of those constitute this base of a value less than 1 but greater than 0. Many of these domains many of these properties are the same. So here we go. The domain is still all real numbers. The range is still a set of positive real numbers. Okay, I still don't have any x-intercepts, and the y-intercept is still at 1. You're still going to have a horizontal asymptote, except this time, this horizontal asymptote happens when x approaches positive infinity versus negative infinity from the prior set of properties. And your HA is still at y equals to 0, okay? Now, because your base, okay, remember A is your base, okay? I want you to remember this. Your base is positive, but less than 1. It's a decreasing function, but it's still a 1-to-1, okay? You're still going to have your 3 points. These 3 points are exactly the same as before. And property number 6 is still smooth and continuous with no corners or gaps, okay? So let's look at this example over here. This is an example of a decreasing function, and it's telling me that I need to have a base that's less than 1, but it's still positive. So let's do i.e. How about f of x equals to 1/7 to the power of x, okay? So this point is still there. That point will never change. But this point is 1 comma. Your base is 1/7, so this is 1/7, okay? So 1 comma 1/7. This one over here, look at this. When x is -1, I want you to check this out, okay? When x is -1, it says 1/a. So I'm going to write this piece, 1 over your base. Well, you can't leave it like that, okay? So when you are dividing, you have to multiply by its reciprocal. So this is really the reciprocal 1/7. It's 7. So guess what? When x is, I'm sorry, this is -1. When x is -1, y is really 7. Is that incredible? Okay. And your horizontal asymptote, it's still at exactly the same spot as before. So keep in mind that when you have a -1, you have to take its reciprocal of the base, okay? All right, we are now going to do example 2. Use transformation to graph. Determine the domain and range. State the horizontal asymptote. So what that means is I want you to state the horizontal asymptote for the end, okay? So we are going to start with the parent. Your parent function is going to be f of x equals your base, which is base of 2, to an exponent of x, always. You have 3 points. Your 3 points will always be 1, comma, base, 0, comma, 1, and -1, comma, 1/base, okay? Because these are generic ones, I'm going to tell you the base for this particular problem is going to be unit of 2, right there, okay? So my 3 points are 1, comma, 2, 0, comma, 1 stays, -1, comma, because it's a negative, you're going to take the reciprocal of your base, which is really 1/2. So these are the 3 points I'm going to use for graphing and transformations after. You will also have to have a horizontal asymptote at y equals to 0. So HA, y equals to 0, okay? So let's plot. 1, comma, 2 goes here, 0, comma, 1 goes here, and -1.5 goes there. I'm going to try not to touch your asymptote, okay, and still be smooth and no corners or gap. So that's our parent function. This is the parent function, okay? And we are going to go from left to right. Our next function is y equals, which I can also use f of x. You can choose 2 to the -x. And I need to state the transformation. So the transformation is a reflection about a blank axis. Can you tell me what axis this is reflected about? So it's a reflection about an axis. I hope you said y-axis, okay? Because it's a reflection about the y-axis, the x will change. So all the x are now negative and the y will stay the same. So this is your formula, okay? So I have the points here. I'm going to use the points again. All the y's, I'm just going to copy it over. Something, comma, 2, something, comma, 1, and something, comma, a half, okay? All the x's are now negative, so this is going to be a -1. 0 is still going to be 0. And -1 before is now +1. So these are my points. I'm going to graph them out. Because I'm reflecting over the y-axis, the asymptote will stay at the same spot at y equals to 0. So -1 I'm going to go to 2. 0, I'm going to go to 1. And 1, I'm going to be at a half. Okay. And when you're graphing it out, check to see if it's true or if it matches what you're saying. If you're saying there's a reflection about the x-axis, okay, are you when you fold it, is the left on the right and the right on the left? So make sure your statement, okay, matches your graph. Next, we are going to do f of x equals 2 to the negative x, which is already done, minus 3. We're going to state this, translation, 3 units down. Okay, so what that means is, in terms of a formula, 3 units down means my y will change 3 units, okay? The x will stay exactly the same as before. So before we have negative x, I'm just going to copy negative x over. So all the x's are exactly the same as before. So I'm going to copy the x's over. Negative 1, 0, and 1. Okay, now the y values is what's going to change. 2 minus 3 is now negative 1. 1 minus 3 is negative 2. 1/2 minus 3 is now negative 2 and a half. Okay, so those are the new y values. Now, because we are translating down 3 units, your horizontal asymptotes has to go down as well. Okay. So HA, y equals to 3, I'm sorry, negative 3, y equals to negative 3. Okay, so let's plot the points. Here we go. Negative 1 is now negative 1. 0 is at negative 2. Positive 1 is at 2.5. Okay, so arrows on both ends. So we have graphed all 3 graphs using stages. Okay, now we need to state the domain and range, and you only need to do it for the final graph. The domain, according to the properties, it should be all reals. Okay, the range, because we shifted down 3 units, the range is going to be greater than 3. Okay, if we didn't shift at all up or down, then it's going to be bigger than 0. Then you have an HA at y equals to negative 3. Usually the HA sort of matches up with your range for a little bit. Okay. If I'm going too fast, make sure you hit pause and finish writing before you move on. Okay, that's the beautiful thing about video notes. You can pause anytime you want. All right, example B. This one says f of x equals negative 3 to the power of x minus 3. So of course we are going to start with the parent. Okay, it's going to be f of x equals e to the power of x. So I'm going to remind you the 3 points are that we will always use. 3 points are 0, 1, 1, your base, and negative 1, 1 over your base. Okay, so our first 3 points are 0, 1, okay, and 1, your base in this problem class is e, and e is about, if you use your calculator and you hit e and you hit equals, it's about 2.718. Okay, so I'm just going to leave e as e, but when you plot it out, e is about 2.718. Then you have negative 1, that's going to do negative 1, 1 over e. Okay, so keep that in mind. And first things first, we are going to start with the horizontal asymptote at y equals to 0. So this is your horizontal asymptote. Okay, so now I'm going to plot the point 0, 1. Okay, 1, e, and again, e is 2.7-ish, so I'm going to go past 2, underneath 3, but above 2. Then I have negative 1, 1 over e, it's obviously less than 1, so I'm going to make any dot in between 0 and 1, okay? So this is my dot, curve that, connect those, make my dots bigger because it looks like I'm kind of covering them up. So those are them. So that's your parent function. The next one, I'm going to use a different color because it looks like I kind of wrote all over. your equation is going to be f of x equals negative e to the x power, okay? And this is a transformation, reflect about blank axis. Can you tell me which axis? Did you say x? I love you. Thanks for saying x, okay? If you didn't, it's actually x, okay? So now that I have those, I'm going to start with my HA. I don't have to change my HA because if I'm reflecting over the x-axis, my HA should be the same, okay? If I'm reflecting over the x-axis, your y value should be opposite. So it's really x comma negative y. So my points are, which I'm going to write up here, all my y's are now, it's opposite, okay? All my x should be exactly the same, okay? So the first one used to be positive 1, is now negative 1. The second one used to be positive e, is now negative e. The third one used to be positive 1 over e, is now negative 1 over e. See that right there? Okay, because I wrote a bunch of stuff on the bottom, so I want to make sure I'm using a different pen here so I can plot my dots. 0, negative 1's right here. 1 comma e. Remember, e is about 2.7, so that's going to be 1 comma in between negative 2 and negative 3. And negative 1 comma 1 over e. So that's slightly in between 0 and negative 1. And connect all those dots. Okay, so make my dots bigger to make sure your teacher can see. So that's how we reflect about the x-axis. Our next function is the last one. F of x equals negative e, we did that, to the power of x, and now this minus 3 is tiny. It's only with the x, okay? Because it's only with the x, we are going right 3 units. Because we are going right 3 units, the x's are all adding 3, and the y will stay exactly the same as before. So, but before, we had a negative y from stage number 2, so I'm going to put that negative value back, okay? So in theory, the y value should be identical to stage number 2. So I'm just going to write the points out with the y value, just copy over from this one. So that first y value is negative 1. This is negative e. And this is negative 1 over e. Then what I'm going to do is I'm going to take all my x values and I'm going to add 3. So 0 plus 3 is 3. 1 plus 3 is 4. Negative 1 plus 3 is now 2. Now because I am moving right and left, my HA is not going to go anywhere. It's going to stay exactly at the same spot. Okay, so HA is still y equals to 0. Okay, so here are the dots. 1, 2, 3, negative 1. 4, negative e, which is about negative 2.7, so it should be right there. 2, negative 1 over e, which is in between 0 and negative 1. Okay, see that right there? That looks great, isn't it? So now that we have it, let's find the domain. Domain, according to our properties, it should be all real numbers. The range, okay, because we reflected it over the x-axis, is now y less than 0. It wants you to state your HA is now y equals to 0. Box them all up, okay? And that is our example 2b with the e value in it, okay? All right. We do have, I think in your notes, we have, and let me go check. So in your notes, I do see that there's example C. So let's go and start this, okay? And again, we are going to start with 3 points, 3 common points. So make sure we would know. It's going to be 0, 1, 1, your base A, and negative 1, 1 over your base. Okay, these are the 3 points you're going to need to know. We will start with the parent over here. Your parent function would be f of x equals 1 over 4, which is your base to the x power. So let's look at your points. 0, 1. When I put in 1, I should have my base. My base should be 1/4. And when I put in -1, 1 over 1/4, you need to take its reciprocal, so it's now 4. Okay, so this one right here, you need to take its reciprocal, which is AKA, you can flip your base. Okay, there you go. And again, we will start with the asymptote at y equals 2. Y equals 2, 0. Okay, 0, 1, 1 comma quarter, which is over here. -1, go up to 4, which is over here. According to your properties, because the base is positive, but it's less than 1, I have a decreasing function, which is a true statement. Okay, so that's your parent function. Then the next one, we use a different color. Y equals to 3 times your base of 1/4 to the x power. You can use your dot as multiplication, or you can use parentheses as multiplication. Because this is 3 times being in the front, we are going to do vertical stretch. Vertical stretch factor of 3, okay? Since you only have one transformation, the third grid is not needed. What does that mean by vertical stretch factor of 3? That means the x is going to stay the same and the y value will be increased by 3. So your points, okay, because it's vertical stretch, 0 times 3 is still going to be at 0. So we're going to keep your HA at 0. Okay, so my points will be, the first one, I'm going to keep all my x's the same. Okay, the second one, I'm going to keep my x the same again, and the third one, negative, is still going to be the same. Then I'm going to 1 times 3 is now 3. 1/4 times 3 is now 3/4. 4 times 3 is now 12. Okay, I'm going to use a different color to plot my dots. So 0, 3 is now here. 1 3/4, that's still less than 1. Okay, so that didn't change in theory on our graph, but it changed in values. -1 all the way to 12. So I'm just going to make 2 more tick marks to go to 12. Okay, so now I'm just going to graph that out, go up. Notice how I'm getting a lot skinnier here. Okay, shooting up a lot faster. So that's what I'm supposed to look like. Since the 3, it's the only transformation, that's all we need to worry about. So let's state your HA. Your HA maintains at y equals to 0. Your domain will always be all reals. Your range, because we didn't translate up or down, it's just going to be greater than 0. Box it up. That concludes our day. Have a wonderful day, and I will see you in class.